Goedenavond allemaal. Van harte welkom bij de livestream van Logos Instituut. Dit is de 7e livestream van een maandelijks gebeuren waarbij we proberen om Nederlandse en buitenlandse kennis op een interactieve manier bij elkaar te brengen. Vanavond hebben we een buitenlandse spreker, maar hij is in Nederland, in de studio hier op Urk. Voor meer informatie over de komende events kunt u kijken op logos.nl, onze website, of ons YouTube-kanaal. Als u zich abonneert, wordt u op de hoogte gehouden. Fijn dat u er bent vanavond. Mijn naam is Frans Gunink. Ik ben betrokken bij het bestuur van het Logos Instituut en heb zelf in mijn eigen leven ook mogen ervaren wat het belang is van het nemen van de schrift als waar. En dat de schrift betrouwbaar is en daar waar Genesis spreekt over de geschiedenis van de aarde, van de mensheid, om dat ook als historisch op te vatten. En de schrift, het woord van God, is betrouwbaar, van het begin tot het eind. En het belang daarvan, voor ons zelf, maar ook voor de mensen in onze omgeving, jonge mensen, om dat uit te dragen, is van groot belang. En daarom doen we het werk wat we doen met Logos Instituut. Dat vinden we belangrijk. We hebben op dit moment 4 mensen in dienst. En samen met iedereen die betrokken is bij Logos, door het lezen van ons blad Bijbel vast, maar ook door gebed, door het geven van giften, willen we werken om kennis bij elkaar te brengen. En dat mensen informatie kunnen vinden. En waar het bij Logos om gaat, is dat we graag heldere antwoorden willen geven op de grote vragen van deze tijd. Vragen over Bijbel, geloof en wetenschap. En ieder mens heeft vragen over: waarom ben ik hier? Waar kom ik vandaan? Waar ga ik naartoe? En dat alles heeft te maken met de Bijbel, met ons geloof en met de wetenschap. Deze livestream, waar u nu naar kijkt, wordt uitgezonden via YouTube en via Facebook. Vanavond is onze gast Philip Bell. Philip Bell komt uit Engeland, zoals ik zei. En hij is een wetenschapper, heeft lang gewerkt in kankeronderzoek, heeft ook les gegeven. En zijn hart klopt voor dit onderwerp, dat zult u merken. Vanavond spreekt hij over de ijstijd. Een onderwerp wat niet zozeer actueel is, want dat is al een tijd geleden. Maar het is wel een onderwerp wat is terug te vinden. Op het moment dat je door Nederland gaat, vandaag was hij in de gesteentetuin in Schokland. Daar vind je zaken die te maken hebben met de ijstijd. En ook elders in Nederland, de Utrechtse Heuvelrug, wordt toegeschreven aan de ijstijd. Philip zal zijn presentatie houden, dat zal zijn in het Engels. Aanvankelijk werd aangekondigd dat het live met vertaling zou zijn, maar we hebben ervoor gekozen, ook om niet te veel tijd af te snoepen van de presentatie, om de presentatie in het Engels te houden, maar het zal goed begrijpelijk zijn, ook voor mensen met een basiskennis Engels. En daarna zal het, binnen een periode van enkele weken, zult u het kunnen terugzien op de website met ondertiteling. Na de presentatie zal het tijd zijn voor een vragenronde. Dan zult u mij ook weer zien hier. Zal ik de vragen vertalen voor Philip. U kunt die vragen stellen via de chat, YouTube en Facebook. Medewerkers zullen dat bijhouden en zorgen dat dat geordend aan Philip doorgegeven wordt. U kunt tegelijk, als de presentatie gaande is, kunt u al uw vragen intikken en dan achteraf zullen ze besproken worden. De presentatie zelf zal duren tot een uur of 9 en dan hebben we een half uurtje voor vragen. En 9:30 hopen we af te ronden. Dan weet u ook wat er verwacht wordt. Ik wil afsluiten om Philip van harte God zegen toe te wensen en hem vervolgens het woord te geven. Floor is yours.
Thank you very much for the introduction. And I'm talking, as you've heard, on ice, the Bible and time. So I'm hoping in a moment you'll be able to see my first slide. Or you can think of this as a presentation on the Ice Age and the Bible. So at the moment I can't see my first slide on the screen, but I'm hoping you can. We have a technical problem, I think. Yeah, I'm not able to see my slide at the moment. Apologies for this. Is the connection? Yeah, but this is not changing. So, as we think about this, we'll see the slide in a moment. I expect when you think about the Ice Age and the Bible, lots of questions come to your mind. Perhaps questions like this: was there such a thing as an Ice Age? If so, how long ago was the Ice Age? Normally when I give this kind of presentation to Christian audiences in a church or other audiences, I first explain the worldview that people have. That's something we do in the organization Creation Ministries International. But I'm going to assume this evening that most of you are aware of the different opinions, the battles for different worldviews when it comes to origins. And I'm operating from a worldview that says God's word, the Bible, is history. And that's a view I didn't used to hold. I used to believe evolution and millions of years as God's method, but I now believe instead that the Bible explains science. But whatever your particular understanding of this issue, I hope that as we look at these questions today, it will be interesting for you. What can we learn about the glaciated regions of the world, where we see ice sheets and glaciers, such as the one at the top left of this picture? What about ice cores, these things that you see at the bottom of this picture? And how can the dates of hundreds of thousands of years from these ice cores be reconciled with the Bible? You might ask also, what about woolly mammoths and cave bears and other Ice Age mammals? How did they get frozen in the rocks, or rather in the sediments that we find in Siberia and in the Arctic? Well, it's an important question, I believe. It's important to Christians as well. Does the Bible have anything to say about the Ice Age? It doesn't mention the word Ice Age, but does it give any clues? Were there many Ice Ages in the past, or just one Ice Age? And if we accept that the Antarctic ice and the Greenland ice were laid down over, or settled from snow that formed ice over hundreds of thousands, even millions of years, doesn't that stretch the time frame in the Bible quite a lot? What happens when we accept deep time is we, I believe, surrender the Genesis record. We say that time is not a matter of history. In the Bible, we are saying that we can change our views. It's true that the Bible doesn't mention Ice Age. In the middle of the 18th century, a few explorers who looked at the scenery in Northern Europe, for example, they wrote about their observations, their beliefs that glaciers had once covered much more of the land than we see today. But it was not until the 19th century that someone put forward the idea of a succession of glacial epochs, ice ages. And this man that you see here, Jens Edsmark, he was a Danish-Norwegian geologist, and he published an idea about these ice ages in 1824. And he argued that it was variations in climate that must have produced ice ages in the past. That was before any of the modern knowledge that we have today. Well, many more people were making observations as they walked in the mountains, in the alpine regions. They could see that boulders had been moved great distances and then dumped in the scenery, dropped. We're going to look at that later. They assumed that glaciers were responsible. And at the beginning of 1837, this man, this German man, Karl Schimper, coined the term Eiszeit, which really means ice age. And that's the time when that word became part of our vocabulary. And it started to become used in English as well about 1855. Well, Ice Age. Now, Ice Age wasn't used until the middle of the 19th century as a word, so of course you wouldn't find it in Bibles in the Netherlands, in Dutch Bibles, in German Bibles, in English Bibles. You wouldn't find this word Ice Age because those were translated hundreds of years before the word was invented. Just like you wouldn't expect to find the word dinosaur in the Bible, or snowmobile, or Microsoft, or computer. But the book of Job in the Bible does have many references to snow and ice. This is an example. A man called Elihu is speaking, and he says, for to the snow, God says, fall on the earth. From its chamber of the south comes the whirlwind, and cold from the scattering winds. And then it says something really interesting. By the breath of God, ice is given, and the broad waters are frozen fast. In other words, the seawater is frozen, solid. And that's a literal translation of the Hebrew. In this verse in Job 38, God is speaking to Job from the whirlwind, and he says, I've got to move it on. Have you entered the treasury of snow or seen the treasury of hail? References to snow and ice, and God is asking Job about this. What do you know about this? How does this happen? And then we see this verse, interesting verse. From whose womb comes the ice? Where does the ice come from? God is saying to this man Job. And the frost of heaven, who gives it birth? Do you understand about snow and ice, Job? Of course, the answer is Job doesn't understand. He didn't have understanding of meteorology. And then God says, the waters harden like stone, and the surface of the deep is frozen. Another reference to the freezing of ocean water. And this must refer to very cold temperatures, because when you want to freeze seawater, which is salty, you have to freeze at a lower temperature, because salt lowers the freezing point. Now, I think it's unlikely that Job had visited the polar regions in a boat. He was living somewhere in the Middle East, maybe Mesopotamia, and he was familiar with the fact that sometimes the waters in the sea would freeze over. And so that is talking about cold conditions in the Bible. So those are some little clues that the Bible gives that suggest maybe reference to what we might call the Ice Age. Now, in the secular scientific world, they refer to many ice ages. And we're going to briefly look at what they say. In this image, you can see that at the bottom there is a graph. It takes you from, on the left-hand side, the present day, and as you move along the bottom axis to the right-hand side, you're moving into the past. You're moving in through the millions of years. So this runs from 0 million years to 5 million years at the right-hand side. During the last 2.6 million years of time, I don't believe those millions of years, but according to long-age thinking, during that period called the Pleistocene or the Quaternary, there are many ice ages. And if you look at the bottom left of this picture, there are downward pointing blue spikes. Those represent especially cold periods of Earth history. And then in between, there are upward pointing red spikes. Those represent warmer periods. So you call them glacials when it's an ice age, interglacials between the glacials, between the ice ages when it's warmer. And they will tell us that at the moment we are in an interglacial. We might go into another ice age at some point in the future. And this is the idea. How do you form these ice ages? How do you start ice ages? Well, in fact, some secular scientists believe there may have been 50 ice ages during the last 2.6 million years. And a man called Milankovitch came up with a theory which said that changes in the way the Earth relates to the Sun, its orbit might become more eccentric. If you look at the Earth around the Sun, it's mostly circular, a little bit squashed. We call it an ellipse. But over time, that might become more squashed out, a more eccentric orbit, and that changes the amount of sunlight reaching the Earth. And that can result in cycles of slightly colder, slightly warmer, over a period of tens of thousands of years. Something else, in the middle picture, the obliquity. It means the change in the angle of the Earth's axis, the tilt of the Earth. And also the precession, the way the pole of the Earth moves around in its as the Earth is going around the Sun in its orbit. So these three things, you don't need to understand the details, but these three things all cause cycles that last thousands or tens of thousands of years, according to Milankovitch, that change just exactly how much sunlight reaches the Earth. These very small differences in the amount of sunlight reaching the Earth changes how warm it is, how cold it is. And somehow this is believed to cause ice ages. They say, as I said, sometimes that there are 50 of these in the past. And this is called the astronomical theory of ice ages. It's still a theory. Not all scientists accept it. And I think it's actually a very weak explanation because the amount of cooling or warming is very, very slight. It's not very significant. Now, there is evidence for an ice age, and that's important to realize. There's good factual support for one ice age, what conventional scientists would call the last ice age. I believe it's the only ice age. We're going to look at some of these. Glacial till. I'll explain these in a moment. Scratch bedrock and boulders, scratch boulders. Eskers, drumlins, Boulder Erratics, and other things. These are things we find in the scenery today. We see them as we walk around the mountains today, and they are strong evidence that there has been ice that has been in that place, but it's subsequently moved away. It's melted away. Now, we generally think of ice as hard and brittle, as solid, but actually under pressure, ice can behave more like a plastic, and it can flow. And so we have to understand that ice is moving. The ice sheets are always moving, and so are the glaciers. In this case, we have a picture of a glacier, and under its mass, under its weight, the gravity pulls down the glacier, and it will move down its valley. During the summer months, more melting occurs, particularly at the bottom end of the glacier. Icebergs form at the edge of the glacier, especially when it moves into a lake or into the ocean. Also, you can have some loss of ice from sublimation. That is where ice immediately becomes a vapor without going through water, liquid water first. These ways remove ice. But then, particularly during the summer, particularly during the winter, then you have an addition of new snow that falls at the top and adds to the mass of the glacier. The glacier is always moving downhill. If it's in equilibrium, if the amount of ice being added at the top of the glacier is equal to the amount of ice being lost at the bottom end, it seems to stay where it is. It is in mass balance, we say. Okay? But if you have an increase in the amount of ice that's being added at the top compared to the amount of ice that's being lost in summer, then the glacier will advance. It's always moving down. When we say advance, we mean that the net movement is down the valley. But if the opposite is true, the glacier will retreat. We don't mean it's moving backwards. It's always moving forwards, but it seems that it's melting backwards. Now, let me show you an example of that. This picture is in Canada. In the background, you can see the snout, the front of the glacier. It was moving towards us in the picture. And in 1992, someone placed a big stone and a marker, and you can see that since that time, the glacier has retreated. That means it's melted backwards, okay? And notice the valley shape. At the top of the picture, it's U-shaped. And that is very classical glaciated sceneries. Valleys form from rivers carving a valley. That's a V shape. But they also form from a glacier, and that carves the valley. It forms a U shape. And this example is a very nice one. This is another example. In this case, the glacier has now gone completely. This is a glacier in a valley in Norway that was carved out by a glacier, and it's a U-shaped. Very steep sides, quite a flat bottom, and this is very, very obviously pointing to past ice. It's gone now, but it was there in the past. Now, in this picture of a large glacier, sorry, I didn't move on. That's the one in Norway. So you can see that steep-sided valley, U-shaped. But in this picture, you see a glacier in Pakistan. And it's moving towards you in the picture. Too slow to see, but I will show in a moment that there are ways of seeing the movement. The dirty surface, the muck and debris on the surface, that's because the glacier is scraping away at the sides of the valley, scraping away rock, and that rock falls onto the surface of the glacier. As it continues to move down, it forms like a dirty line, a dirty stream on top of the glacier. Now, for some people, they think ice doesn't really move. They're skeptical. Well, it does move. And there are various ways to show this. Here is a very famous glacier in Argentina, the Perito Moreno Glacier. And you could use time-lapse photography, and you could speed it up, and you would see this glacier is moving down like a white river of ice. It flows fastest in the middle and slower at the sides because of friction with the sides of the valley. You can use various methods to check the movement of a glacier. Under Mont Blanc in France, a scientist found a cave, and he could see the ice passing above him, and he took a bicycle wheel and he put it against the ice, and as the ice moved, the wheel turned, and he measured the movement with a meter. So it's moving. This particular glacier, at the bottom end, ice falls into the lake. And this is a picture of the top of the glacier, and you can see, well, take my word for it, from the left-hand side to the right-hand side is 5 kilometers. This is a big scale. In the middle, the ice is 74 meters high. That's the height of a 26-story building. But all the time, there are big ice falls. Things the size of skyscrapers, big buildings of ice, are falling into the lake. And it's very spectacular. You can go there, you can stay at a viewing platform, and you can film it happening yourself. If the glacier was not moving down the valley, then it would have disappeared a long time ago, because that ice cannot keep breaking off forever. But new ice is added at the top end. It can be quite fast, this movement of ice, and this is a particular example reported in February 2014. The latest observations of this, I don't know how to pronounce that name, Jakobsvorn, it's an Icelandic name. The latest observations show that Greenland's largest glacier is moving ice from land into the ocean at a record speed of more than 17 kilometers per year, or more than 46 meters per day. That's fast. That's a fast speed. Now, I'm not saying all glaciers move at that speed, but the average is about half a meter, 50 centimeters every day, or maybe up to a meter a day, depends on the glacier. That's fast enough that if you take the world's longest glacier, which is a glacier in Antarctica called the Lambert Glacier, 400 kilometers from the top to the bottom, it would only take 1,100 years to make the full journey, even at that speed of maybe 50 centimeters to 100 centimeters per day. But it could have moved much faster in the past. By the way, this glacier, they think it's the source of the iceberg that sunk the Titanic in the early 20th century. That's an interesting thought. I don't know if that's true or not, but it's certainly interesting to think about. That happened, of course, in 1912. Now, when these glaciers have gone, they leave behind evidence. And we're going to look at a bit of that evidence now. I mentioned glacial till. What is till? It's a sedimentary deposit. It's a mixture of irregular rocks, some small, some large, some as big as boulders, some small, some as fine as sand or even clay size, very, very tiny. All of these chunks, these bits of rocks, are incorporated into the moving ice as it scrapes away at the sides and the bottom of the valley. And eventually they're deposited at the edge of the glacier or underneath it. And we call those deposits of glacial till moraines. And here are some moraines. So if you look at the top of the picture, there is an arrow to lateral moraines or side moraines. These are the ones which are piles of debris at the sides of the valley where the glacier has scraped away. When you get two glaciers coming together, like two rivers coming together, two rivers of ice, where their side moraines meet, they continue as a medial moraine. And that's how you get these lines in the middle of the ice, on top of the ice. And then at the very end of the glacier, it pushes the dirt up because it's really heavy, the ice. It's pushing the material up, and it leaves a terminal moraine, a moraine at the terminus or the end of the glacier. And that's often a crescent shape, like a half moon shape. Here is an example of some lateral moraines and some medial moraines in the Alesh Glacier in Switzerland. Okay? I think they're quite attractive, these rivers of ice. If you go on YouTube, you can look at time-lapse photography of these sorts of glaciers moving downhill like a river. And here's another example. This is a lateral moraine. I've got arrows here to show that lateral moraine. And in the middle, you could see medial moraines because the glacier has retreated. It's left these piles of debris. This one is above Lake Louise in Alberta, in Canada. That is proof that this has been glaciated, even though the ice has disappeared. Here's an example of a terminal moraine. I'm pointing you to it with 3 arrows. And the glacier has begun to retreat. It's not moving backwards, remember. It's still moving forwards, but it's melting backwards. And here is another example. The river of ice at the top of this, sorry, there's the one, I didn't forward it. The terminal moraine. Here's a better example. The river of ice at the top left of the picture is coming down, and it's moving to the right-hand side into this lake. But before the lake existed, the glacier existed all the way to the right-hand side of the picture. And it pushed up a very big ridge of debris, which is now a moon shape or crescent shape. And that is shown by those arrows there. A terminal moraine. And today you can see these moraines hundreds of kilometers away from any ice. But they are absolute proof that there was once ice in this area. It left these classical signs in the scenery. Okay, just one more example. Here is a person. I don't know if you can see the person in this picture. This is an Alaskan glacier, and you can see that there's the snout of the glacier, the end of the glacier, and there is the big pile of moraine. So the scale of some of these moraines is quite big. They can be many times the height of a building. So there's some evidence. I've mentioned glacial till. I've mentioned moraines. Sometimes they scratch the surface of the rock underneath the glacier. With the rock that is being carried along by the ice, under this great pressure, it scratches the bedrock. It scratches those boulders as well. I'm going to move on and talk about eskers and then Boulder Erratics. Just some examples. And here we see an esker. It's a sinuous ridge. You can see the picture of it winding backwards and forwards, like meandering through the valley. And this is, there are 2 examples here from North America. When a river forms underneath a glacier, particularly in summer, the meltwater from the top of the glacier pours down the crevasses, the big chasms in the ice. It reaches the bottom of the glacier, and it moves underneath in a course like under the glacier, a stream, subglacial river or stream. It's carrying lots and lots of debris, lots of rocks and bits of broken rock, and it is able sometimes to carry them for a distance before it drops them. It drops them because the river gets choked, and after the glacier has gone, you see the path of that subglacial stream marked by what we call an esker, a ridge, and it can travel these can be many, many tens of kilometers long. Interesting and very, very clear sign of glaciation. There's no ice to be seen today, but you could be certain that an ice sheet once covered these areas. Here's another example. This is moving across the picture from left to right. And when you cut into these, you don't find debris sorted like it would be with a river. You go from coarse-grained to fine-grained, what we call grading upwards. You instead see lots of debris of all shapes and sizes just together, big mixture. And that's very strong evidence for a glacier. And then we find Boulder Erratics. This one's in Scotland. And it's a big boulder, sometimes much smaller, but a big boulder that has been dropped in the scenery. It doesn't have the same rock type as the rocks underneath. We call it an erratic. How do we explain it? It's not water transport. It wasn't brought here by big floods on the top of this mountain. No, it's the wrong shape. It's too big. It doesn't have the corners knocked off. Here are some more examples. These are in different parts of England and Europe, Finland, Greenland, Scotland, Yorkshire. It looks a bit like someone has put them in the scenery for a joke, but I can assure you that's not the case. Some of them are massive. They've been left behind when the ice melted. They were carried along on top of the ice sheet or the glacier, and later on, after the ice melted away, they were left where they were. But they were carried for hundreds of kilometers from where that rock type exists. Here are some examples which I photographed today. Man that you see in the picture, Kees van Helden, helped me by standing in the picture to give you scale. These are not so big, but here you have in Holland quite a lot of evidence of ice once covering the scenery. And these are angular. Some of them were made of granite. Different rocks. Most of these are coming from a long way away from the Netherlands, maybe from Scandinavia. They've been carried there and they have been dropped by the ice. So those are some evidences in the scenery that we see. And ice ages are believed to take place in the past Earth history, going back millions of years. But I ask the question, is there evidence in the rocks for those past ice ages? Now, some people say yes. We find what looks like that till, that poorly sorted, angular, rocky debris. We find that lower down in the record of the rocks. We call it a tillite. We also find some scratch marks sometimes, and that seems to indicate past movement of ice, scratching the rock. We also find rock flour, really finely fine rock dust, which has been made as the ice scratches the rocks. It's a bit like it pulverizes it, it grinds it really fine to make a sort of rock flour. And then we find drop stones. Drop stones happen today if you find a big glacier with, an iceberg which has a big rock in it, and then as the ice melts, that falls down through the seawater or the lake water into the sediments at the bottom of the sea or the lake. It's a stone that's dropped, and it drops into the sediments, and that is clear evidence for ice age. But people sometimes say, well, if I see some layers of sediment deep in the rock record with what looks like a drop stone, this is evidence for a past ice age. And I think that's fair enough. It's a theory. But are there other explanations for the same facts? And there are. And I'm going to give you one example. Here are rocks that have been scratched. You can see the parallel lines coming from the top left to the bottom right of this picture. And this looks just like scratches that you would find in glaciated regions. But in actual fact, this formed in one afternoon when Mount St. Helens erupted in May 1980 in Washington State, USA. Pyroclastic flows, very fast, superheated clouds of gas and ash and bits of rock, pumice, were blasted out of the mountain top, and they rushed at maybe 200 kilometers an hour, and they caused scratches on the rock surfaces. It looks like maybe an ancient ice age, but if you find those scratches deep in the rocks. But there can be other explanations, like volcanic activity. And we could say the same about some of the tillites, the poorly sorted angular debris. Some people find these and they say, we think there was a glaciation more than 2 billion years ago, 200,000 million years ago, the Huronian glaciation. But it's much more likely that they're looking at debris that resulted from giant submarine landslides. When tsunamis happen because of earthquakes, what happens is sometimes the continental shelf material slips suddenly. That displaces the water, causes a tsunami, like happened in Japan a few years ago. But that slump of material can travel for a long way, sometimes hundreds of kilometers, and it's not happens by water, just normal action of rivers, and so you end up with this debris flow, and it often is very poorly sorted, and that can be an explanation for these so-called tillites. So I showed you earlier this statement, but I think there are good explanations for all of these. Now, I haven't got time to go into that in any more detail, but I want to move on now and talk about this ice age. So we've seen that people claim there were lots of ice ages. I believe we have good reason to believe in one ice age just from the physical evidence. That's the science of geomorphology, the shape of the earth, or to be very specific, glacial geomorphology, the shape of the scenery caused by past movements of ice. And that's good evidence for one ice age. If you go to Greenland, you will find that almost the whole country is covered by this ice. And the ice in the middle is 3.4 kilometers deep. The Antarctic ice sheet is even deeper, 4.2 kilometers deep. And biblical creationists accept that this ice you find in Greenland, in Antarctica, and a few other places is strong evidence for an ice age. When did that happen? How did that happen? That's what I want to talk about. One ice age, I believe, it came after the flood of Genesis in Noah's time. This world map shows the likely extent of the last ice age. This is, by the way, information all people who study this subject believe. People who believe in evolution and millions of years, who study ice ages and they believe in millions of years, they still accept what I'm showing you. Notice that the ice does not cover the whole world. Africa was never glaciated. Australia was never glaciated. India was never glaciated. Most of the United States was not glaciated. But ice covered Greenland, it covered most of North America and Canada. It covered some, but not all of Alaska. It missed out the coasts of Alaska. That's interesting. It covered a lot of the Arctic region and Siberia, but it missed out some of the Siberian coasts. Very interesting. A big mystery to people. Why did those areas not get glaciated when they're so far north? Well, one ice age. 30% of the land at the maximum was covered by ice. Now, some people say it's pretty easy to start an ice age, and they point to those Milankovitch cycles, but the truth is it's not so easy. Here's a book about the ice age in the Lake District. The Lake District is a place in northern England where you find a lot of scenery that shows strong evidence of ice. And it's no longer there, but it's interesting evidence. This man says in this book about that, it takes relatively little change to plunge us back into a situation where ice could start building up again on the hills. Well, no, it's not easy. That's actually a myth. It's a falsehood. It's not easy at all. Now, I could spend a lot of time sharing with you quotations from secular scientists to show that it's not easy. Here's one example. Why the ice periodically advances and why it retreats again is a mystery. That was in New Scientist magazine in 2010. New Scientist is a very strong secular evolutionist deep time publication. They're not in any way sympathetic to the position I hold this evening. And let's go to that fountain of all knowledge, Wikipedia, and this is what it says. The causes of ice ages are not fully understood. No one knows. There have been whole issues of journals, scientific journals, dedicated to this mystery. And it's considered to be one of the big mysteries. How do you start an ice age? Nobody knows. And so they're still guessing at how that might happen. One of the problems they have is this. To start an ice age, paradoxically, you need warm oceans so you can have lots of evaporation, lots of precipitation of snow and ice at the polar regions. But you also need the Earth to be cooled down at the same time. And if you try to cool down the Earth slowly in ice age models, you slow down the evaporation from the oceans. It makes it extremely difficult, if not impossible, to build up ice at the poles. Okay? And that's an important observation. Now, when we look at ice cores, and this is Antarctica here, and in the middle of this map is the South Pole. When you look at Antarctica, they say that the ice there formed, first of all, 30 million years ago, and it reached its present size, this ice sheet, 15 million years ago. And they've been drilling ice cores, like drills down into the ice, since the 1960s, and they believe that the age of the ice, the oldest ice, is more than 1 million years old. But there are some things to consider. A lot of the time, it's much too cold to form ice. You probably know that for snow to settle, it must, first of all, be the right temperature. If you go down to -4 Celsius, it's already too cold to get much snow. It needs to be a little bit below freezing, but not too cold. A lot of Antarctica has dry valleys. Actually, quite a big area of rock is of the South Antarctica's dry valleys. These form in areas where it's too cold, and therefore the ice that does exist just evaporates, it sublimates straight into vapor. And these valleys are big in area. The total area is 4,900 square kilometers. This is just a few hundred kilometers from the South Pole. No snow at all. This is an example of one of those valleys, the Wright Valley. And, it might be an average -8 degrees Celsius or more, and it's just debris on the surface. Cold on its own will not result in snow and ice building up. You need more than just cold. You need to have a lot of precipitation, a lot of evaporation from the oceans that falls as snow. So this is actually one of the world's most extreme deserts here. There is no life at all of any kind, not even bacterial life in these dry valleys. Now, when we go to the ice cores that we find from Antarctica or Greenland, they're interpreted to give ages that are much bigger than a Christian who believes the Bible's history is thousands of years old. Greenland ice is supposed to be up to 100,000 years old, okay? And this ice core you see being handled on the left-hand side is taken from the GISP-2 core that you see in the middle of the map there. But you cannot count 110,000 annual layers. That is an assumption. So notice something here, and I'm going to tell you something a bit complicated, so concentrate with me. This is a model, first of all, for how ice flows. This is, imagine this is a big sheet of ice, snow falls at the top, layers form, And as the ice compresses, as the ice moves down, as more snow falls, more ice is added, the layers get thinner. But the ice is also flowing out to the outside. All around, the ice is flowing away from the center of the ice sheet towards the edges. And that stretches out these layers, makes them very thin. So that means that this ice is behaving in a plastic way, and as it goes to the bottom of the, of the ice sheet, it's actually moving sideways more than it's moving downwards. So it's not possible to count layers all the way to the bottom. You would have to actually start counting sideways if you could even do such a thing. So that's an ice flow model. And these models are used to help interpret the ice cores that we find. Now, ice cores are not something where you just count the layers of snow. Below about 500 meters, it's totally impossible to count layers. So scientists use proxies. They use substitutes for temperature. What they do is they count things like heavy isotopes of oxygen or heavy isotopes of hydrogen, or they count scattering of, they count dust layers, the way that they scatter laser light. They have many sophisticated ways of counting of layers of dust and chemicals in the ice. Okay? And then they use these things as substitutes to give them a clue to how hot or cold the world was at the time the ice that they're looking at was laid down. That's complicated. I know it's complicated. And let me explain this a little bit more. There's a lot of circular reasoning involved in ice core dating. The ancient universe is assumed at the start. Billions of years, hundreds of millions of years for ice is assumed. Precipitation's too low to count those layers, so they get isotopes of oxygen and hydrogen, different forms of those elements, and they don't date sea ice, but they date sediments on the seafloor, muddy sediments on the seafloor. Okay? Based upon those readings of the amounts of oxygen and hydrogen isotopes in the seafloor sediments, they then calibrate the ice cores that they find. But those seafloor sediments, first of all, are calibrated by Milankovitch theory, the astronomical ice age theory. So there are several steps before you even get to the ice cores themselves. And then the final modification of the ice flow of the ice cores is that you have an ice flow model I showed you earlier. That also influences how you assign an age to the ice cores. You don't read an age straight off the ice core. Many steps go into that. And of course, the assumption at the beginning is that Milankovitch was correct in believing how ice ages start and how they change and how they come how the ice retreats and advances. Very complicated. You'd have to study this yourself to begin to get your head around it, to begin to understand it. And they produce these sorts of pictures like you see here. And this is a typical ice core graph. I'm not going to explain it all. I just want to say this. We don't ignore these things. Scientists who believe in creation don't ignore these things, but we interpret those ice core graphs differently because we have a different starting point than the secular ice age models. We don't believe in calibrating the ice cores by looking at seafloor sediments and by looking at Milankovitch theory. But we don't ignore the data. And so you can see, I've added on this picture, that bottom part of a typical ice core graph, we interpret as the warm period after the flood. If there was a flood in the days of Noah, oceans would be warm after the flood for maybe hundreds of years. Why? Because the Bible tells us fountains of the great deep broke open. They added a lot of lava, a lot of hot rock, a lot of hydrothermal water from below. So oceans would be warm. We'll come back to that. So that's represented on this graph here as the graph moves to the left. But then it moves back as the ice age begins, and you see that there's a little bit of a movement back. Then the big thick part of the graph going up, the top part of this graph, the top 1,500 meters of this core, that represents the passage of time coming up to the modern day. Now that's a bit complicated, but the point I'm making is we don't ignore the facts. We interpret them according to a different model, starting with the Bible's history. Now let's recap. That's quite complicated. Let's come back. At the present rate of precipitation, the rate at which we measure today that snow is landing on Greenland's ice and on Antarctica, then you could form the Greenland ice sheet in 5,000 years and the Antarctic ice sheet in over 10,000 years. It doesn't take millions of years, okay? And that's assuming the present rates of precipitation. If there was much heavier precipitation in the past, these times would be much shorter. They could be much, much shorter. So ice accumulation times could be much less. I believe they were much less, and we'll see some reasons why. Here is a picture of the east coast of Greenland, some of the ice sheets there. And there's good evidence for what I've just said from a story I'm going to tell you about the Second World War. 8 American planes were headed for an airfield in the UK to join the war effort. But they ran out of fuel, so they had to turn back. They turned back because of a blizzard, big heavy snowfall. But they couldn't get all the way back to the United States, so they crash landed on this ice sheet on the east coast of Greenland. There was six of these P-38 Lightning fighters and one B-17 Flying Fortress. The people were fine, they were rescued, and then the planes were left behind. But these are now precious planes, and back in the 1980s, some people decided we're going to go and find these planes, and they looked for many years. And then, after many years, they found this lost squadron of aeroplanes. They found them about 4.5 kilometers from the original site where they crashed, and they found them 75 meters deep. That's the height of a 25-story building. That was in 1988. A few years later, they were able to start retrieving these planes. And what they did was they built this thing called a super Gopher. You can see the picture in the bottom left. It's coiled copper pipes. They ran hot water through it, and this sunk down through the ice all the way to the planes so that they could go down that shaft, get to the planes, break up the planes carefully, and pull the parts to the surface. Okay? So they were very dedicated. We wrote about that in our Creation magazine a few years ago. And then they even rebuilt one of them, and they flew it again, and they nicknamed it Glacier Girl. Okay? I think they must have added some new parts to help it fly safely. But that's an interesting story. But I was most interested in what it tells us about the speed of ice formation. The team had only expected a small amount of ice and snow. Instead, they found that there were many meters of ice. In fact, back in 2016, they returned, and the depth of ice above the plains was 120 meters. Yeah? So in just in less than a human lifetime, 120 meters of ice. So building up ice quickly is not a problem in the Bible's time frame. Now, it's true that ice does not form so quickly in the middle of Greenland where it's colder. It depends where you are on Greenland. It depends where you are in Antarctica. But it can happen quickly. So there's evidence for this ice age. Now, I'm going to have to go through this quite quickly. I'm going to give you pointers to resources at the end to help you. We can think of this as a biblical model for the ice age. Okay? First of all, we know that the features that we found, like eskers, glacial till, moraines, these are found in the surface, above sedimentary rock, which contains fossils. Fossils are dead things. I believe most of those come from the flood of Noah. So these features of the scenery are found above the rocks where we find evidence for Noah's flood. That means that we're talking about an event after Noah's flood. There was much volcanic activity in the flood, I believe, the fountains of the great deep. That did two things. It added dust and volcanic particles, aerosols, to the upper atmosphere. That cooled the earth. And we know that that's true today. Volcanic activity can result in cooling of the earth. That probably happened after the flood as well, for many hundreds of years. It's also true that that warmed up the oceans. That increased the evaporation rate of the water from the oceans so that you could have a lot of precipitation, high rates of precipitation of snow at the poles and at the tops of mountains. And so the warm oceans combined with cold continents, because of the cooling effect of the dust in the atmosphere, resulted in a buildup of lots of snow. We can see it in this picture in a different way. Okay? So this is the model. Volcanic activity, dust and ash, cool summers, much less melting of ice in the winter, in the summer that fell in the winter. The mass balance of the glaciers shifts towards building up of ice. And so over time, I think over hundreds of years, you get big depths of ice. Ice would build up in this way until the oceans began to cool down so that there was less evaporation, and also until the volcanic ash cleared from the atmosphere so more of the sun's light could penetrate. And so this would only happen for a period of time. Probably, it's estimated by some scientists, 500 years to reach the maximum amount of ice, glacial maximum. And maybe 200 years to then start melting back of the ice to reach something similar to today's situation. Okay, and that is a short explanation for a biblical model for the Ice Age. And I think it makes a lot of sense. It's consistent with the Bible. Now, I showed you this quotation earlier that at present rates of precipitation, you could build up the ice in Greenland and Antarctica in just a few thousand years. And then this man, Michael Ord, he's a meteorologist, studies the weather. He says, but the ice sheets grew much faster in the post-flood rapid ice age, which lasted about 700 years. There was much heavier annual snowfall, much less summer melting. So the Greenland and Antarctic ice sheets grew rapidly for hundreds of years after the flood, eventually arriving at the general steady state that we observe today. We're still living at a time with lots of ice, but we wouldn't call it an ice age. Okay, so I hope that's been helpful to you. So I'm going to conclude very quickly. In the scripture, here's another verse that mentions ice. Like the cold of snow in the time of harvest is a faithful messenger to those who send him, for he refreshes the soul of his masters. Earlier, I showed you several places in the book of Job where there are references to ice and the frozen seawater. This interesting verse is a proverb of Solomon. It shows that snow in our fallen world is not always bad. Actually, it looks beautiful on the mountaintops, and it can refresh us at a time of heat. And that's a challenge to us all in this verse, if we're Christians, to be faithful to refresh the souls of others. You are refreshed by cool air, a cool breeze of air, or by snow in summer if you're very hot. And God says to the Christian, you be like that. Be a faithful messenger, telling the truth of my word to people in the world, and you will be a refreshment to their souls. Okay? Interesting verse, isn't it? One more slide, and it's just to really close this with a conclusion. I hope that you understand that the great depths of ice at the poles are not a problem for a biblical creation position. Ice, the Bible, and time can be reconciled, but you have to have a different set of glasses. You have to look at things from a different perspective. I've only scratched the surface of a very, very big subject. Later, during the question time, I'll share a few examples of resources you can look at, and maybe you have some questions for me now. So, hand back to France.
not going to give the answers, but just pass on the questions. Zo, dank voor de vragen die gesteld zijn via de verschillende media. We would like to go back to the beginning, and there are some very specific questions. There are different views, even from Bible-believing Christians, on the Ice Age and the dating of the Ice Age. But to start with a very basic question, how did people survive the Ice Age?
That's a good question. If you remember the graph I showed earlier, the graph showed the planet, its geography, and 30% of the world's Earth's surface was covered by ice. There were lots and lots of places where there was no ice. So it's very obvious that people lived not in the coldest places. However, there is evidence that some people lived in Northern Europe, quite near to the ice. They had a very hard life. I think those people we call Neanderthals were humans descended from the people that came out of the Ark. And we see evidence that their diet was very difficult. They had an iodine deficiency, which meant that they got rickets. They had more syphilis. They had more broken bones. They were not able to absorb as much sunlight because they were living where the sun was not shining so much with all the dust. There's evidence for that because we know that the sunlight helps you make healthy bones and healthy teeth because you absorb sunlight radiation, ultraviolet. It helps you make calcium because it helps you make vitamin D. The vitamin D helps you absorb calcium from your diet. That gives you healthy bones and teeth. But these Neanderthal people had many fractures in their bones, poor diet, and they also had a lot of wear on their teeth. They were eating harsh diet. So there's strong evidence that Neanderthals were people living in Northern Europe when it was a harsh climate. But there were people living in other parts of the world as well. There was plenty of land free.
And is there also a connection with the Ice Age and those people in the northern spheres with the mammoths dying out?
Okay, I think so. Maybe I could just say a bit about mammoths, but I would need to show the slides. If someone can show the slides again, I will show about mammoths. Mammoths are one of the Ice Age animals, along with cave bears and other Ice Age mammals. We call them prehistoric sometimes because we think they're before human history, but I think they're part of human history for sure. And mammoths come in several sorts, but we're probably most familiar with the woolly mammoth. This was a creature that was definitely well adapted for the cold, and this mammoth had hair that was 1 meter long. It had lots of oil in its skin. It's slide 76 if you can find it. It had lots of hair in its skin, and this meant that, lots of oil in its skin. This gave it a great insulation from the cold. So it was wonderfully adapted for life in the Ice Age. And of course, you might be aware that people find mammoths and other carcasses of Ice Age animals frozen. So those mammals were living in that part of the world, probably towards the end of the Ice Age when the ice was beginning to wane, it was beginning to retreat. Strong winds would have been blowing off the ice sheet. We have this today. They're called Adiabatic winds. They're like hurricane force winds of cold wind blowing incredibly powerfully off the edge of the ice sheet. And if they flow over land, which is bare, it picks up dust and it can cause great piles of dust. It's technically called loess, wind-blown sediment. And people would assume that an animal that lives in an area with strong winds, it would, in a blizzard, animals turn with their back to the snow. The same with a snow blizzard. The same would be true of a blizzard carrying lots and lots of dust. Just like in the Dust Bowl era in the 1930s in the United States, where houses could become covered up, it's likely that mammoths were covered up by the dust. And then as the permafrost was rising through the sediments, as we see today in parts of the Arctic, in Siberia, these mammoths that had been killed by breathing the dust, we find dust inside their air passages, they were then frozen solid in the dust because the permafrost moved through the dust. It's a really good explanation for mammoths. So people would have seen them. People moved away, but the mammals don't have the same choice. They don't. They only know what they have, and if their instinct is not to migrate, or if they're not able to migrate because of barriers, they perish. They die in that last part of the ice age.
One more. Is that okay?
Yeah, that's good.
One more question. In the North Sea, many bones and parts of mammoths are being found.
Yeah.
Why there? And does this also have to do with the Ice Age?
Okay, we haven't got a picture, but try to remember back to the map of the Ice Age and the maximum extent of the ice. 30% of the Earth was covered. In my own country, in the UK, the ice came down nearly to London, okay, almost in a straight line running east-west across the country. And so a lot of your country, as you bring that ice sheet across the North Sea into the Netherlands, then a lot of this country was covered. I showed you glacial erratics near Urk in the north part of the country, and these were left behind by ice. When you find in the North Sea bones of Ice Age mammals, that's what you'd expect. But some of that area during the Ice Age was not always covered in ice, and some of that, as time went on, the ice retreated, but as the ice retreated, animals could then move into those areas where the ice retreated. Of course, some vegetation would begin to grow during the summer months. They had a form of food, a source of food. But as ice was retreating, it was melting, and one of the things we know happens is that lakes build up behind ice dams. Where that happens, it's a time bomb ticking. And if you get to a certain point where this big volume of water in this glacial lake breaks through the ice like an ice dam, it drains catastrophically. It suddenly flows out. This has happened in North America. It's now accepted that the Badlands of South Dakota were formed by a breaking of an ice dam. The Lake Missoula flood is called. It's also now believed by secular scientists that the English Channel that separates my country from your country was formed catastrophically when an ice dam broke and water flowed extremely quickly down the North Sea and into what is now called the English Channel, carved it out quickly. How do they know that? Because when they go down under the water at the bottom of the North Sea and into the English Channel, they see these big marks running parallel with the coasts, showing that this water moved quickly, carried debris, and scratched the base of the channel. So Ice Age mammals, for a period of time, would have been living in the area that is now covered by the North Sea, and so you find their bones underneath, or their teeth.
Interesting. There is one of the last post questions, and not the last one we will cover here, but an intriguing one. Why is there in all of Antarctica an ice wall, and why can't you go there? And why isn't there nowhere on the North Pole a gigantic wall?
Okay. Yeah, the wall of ice is not everywhere that you go. The first explorers to Antarctic did meet. They expected to get to the South Pole, and when they were coming to the parts of the Arctic they found this big wall of ice. Impossible in those days to climb up the ice. But in other places you can land, and it's more, and you can see some of the coast, and you can get onto the ice sheet. And people do that today, but they also can, of course, fly onto the ice sheet. It's not a wall of ice the whole way round. But the walls of ice happen because you've got an ice sheet moving, and at the end where the ice is meeting the ocean, it drops off in big chunks, like I showed you with the Perito Moreno Glacier in South America. And that means that these big chunks, the size of skyscrapers, fall away. They leave this wall of ice. In other places, you don't have such a big effect because the ice sheet is thin. As it reaches the coast, it's thinner. It doesn't form such a big wall of ice. At the North Pole, you have no land underneath. So if you melted all of the polar ice, the northern hemisphere ice, under Greenland there's land, but under the North Pole there's no ice at all. And that's interesting because if the biblical model of the Ice Age is correct, it means that there was a time when the oceans were still warm after the flood, when the oceans were ice-free in the north. Snow was building up on the continents because of the cool conditions in the atmosphere and lots of evaporation from the warm oceans, but it wasn't building up on the coasts. The coasts were affected by the warm water. That's why we find on the coasts of Alaska and even Siberia completely ice-free regions, because they're right near the coast. They're not very high. And that's interesting because it explains something that you cannot explain with a biblical model, with a secular model. It also means that it would have been possible for early people after the flood, if they wanted, to take a boat and go up past Scandinavia and over the top and actually sail across the top of Russia and down towards China. And there's evidence that people actually did that. There is archaeological evidence in parts of China which shows similarity with the Orkney Islands and with the Shetland Islands north of Scotland. Similar pottery, similar artifacts. There are also maps from at least 500 years ago which show the coastline of Antarctica. Very, very similar to what we know it to be, because we can go beneath the ice with our clever technology. We can use radar penetration technology. And people many hundreds of years ago were drawing an accurate coastline of Antarctica. How is that possible? Because I don't think the ice has been there for 30 million years. There was a time when even that was ice-free.
There's a more specific question. Philip, how can researchers know that the North Pole and the Arctic Ocean was not glaciated during the Ice Age, as it is glaciated today?
How can we know that the North Pole was not glaciated?
And the Arctic Ocean.
We know the North Pole was glaciated. Yeah.
During the Ice Age?
Well, later on. Maybe not at the very beginning, because it was ocean. Yeah. But you cannot determine that from just looking at a map that shows the maximum extent of ice. But I mentioned the oceans were warm, but as the oceans cooled down, as the dust dissipated, it would cause a return to conditions much like we have today. And that would mean that the ice in the northern hemisphere would begin to freeze over. We don't see a passage through the Arctic ice today. When did that happen? No one can be certain, because we were not there. But it seems likely that it began to happen about 600 or 700 years after the flood, during the very end of the Ice Age. And then the oceans would be so cold in winter that they began to freeze completely. And so it's likely, I think, about 6 or 7, maybe 700 years after the flood that you see that taking place. But you cannot actually date the ice to have that answer. And with Antarctica, then I think it's likely, again, similar period of time. Today, Antarctica increases its area many, many times during the height of winter. You can see it on maps if you just go and look. Antarctic ice grows during the winter, and then it shrinks during the summer. So I think we're talking about towards the end of the Ice Age. But to find out more, go to creation.com, type in Biblical Model Ice Age, or type in Michael Ord. Michael Ord has written a good book called Frozen in Time, which gives the Ice Age model. As you mentioned, some people as creationists have a slightly different understanding of the Ice Age. My personal view is that Michael Ord's model is the best we have at the moment. Some people will disagree. I would say to my friends who have a different model, publish your model. Let's see your model. I would be very interested to learn your model. But I think we all agree that we can build good models for the Ice Age based on the history of the Bible. We're not required to believe in millions of years for past Ice Ages.
There is a question here. I think you covered this. What is the biblical time where the most precipitation fell down? You say 500 to 700 years after the flood, most likely.
According to the model which I was working from, the majority of that would have been particularly in the first 400 or 500 years. At the 500 years, you reach the glacial maximum. It's a bit like the supply of evaporation and precipitation is turned off. You need warm oceans to get evaporation. For evaporated water vapor to condense into rain, it must condense onto nuclei very high in the atmosphere. Dust gives you a very good way of condensing lots and lots of water. So those aerosols do two things. They cool the planet, they stop sun's radiation, but they also provide condensation nuclei so you can form lots of precipitation. But once the oceans cool down, once the dust dissipates, both of those factors mean that the precipitation will decrease significantly.
And there are ideas, there are theories, people say that the ice didn't form hundreds of years past the flood, but on the floodwater. So right at the end of the flood. What can you say about that?
I don't think that's very likely, because for it to form on the floodwater, it would assume that the floodwaters suddenly become very cold. You cannot suddenly freeze water. Now, if you look at some movies, they imagine something changing in the climate, and there's a film called The Day After Tomorrow, and this imagines a change in ocean circulation, and this results in very sudden freezing of seawater and of water generally. This is not science. The very fact that we have a lot of water on our planet makes it habitable, because technically water has a high specific heat capacity. It's what we teach school children and science students. That means it takes a lot of energy to heat water up, and it takes a lot of energy. A lot of energy is released when water cools down. So to go from warm oceans after the flood, which I'm sure is true from believing in the flood and the phantoms of the great deep, to suddenly having cooling of the water and forming lots of ice, there's no mechanism for that. That sudden freeze just wouldn't happen. But explore more, as I said, on creation.com to find out more. I just have a quick look here. Have we got? Oh, I thought this might be moving on.
You covered it slightly in the beginning, but why do people conclude that there were more than one ice age? What's the evidence for that from a scientific, secular point of view?
They look at, I mentioned this in the talk, they look at scratch marks that they find in rocks deep in the geological column. So if you look at the geological column, I don't have a picture to show you. You start with the Precambrian, Cambrian, Ordovician, Silurian. You get all of these layers of rock. Then you come up into the Triassic, the dinosaur era, Jurassic, Cretaceous. You keep going up. Eventually you get to the Pleistocene, where the Ice Age happens. This idea is over hundreds of millions of years of time. And they say, well, if you go and find rocks that are from this period, the Ordovician, or even as far back as in time as the Precambrian, more than 2 billion years ago, then you can see evidences of till that's formed tillites. You can see varves, certain types of mud layers, and these are the kinds of things we sometimes see as a result of ice ages. So therefore, we think these are evidences for ancient ice ages. And I'm saying, yes, that could be, but if there are better explanations for those features, then they're not evidence for ancient ice ages. And one of the evidences that I mentioned was the debris that can form by giant landslides under the ocean. These are not something that we invented. They are something we see in our lifetime. And these move at hundreds of meters. They move at hundreds of kilometers an hour, very fast. They break telephone cables that used to, before we had satellites, they would break transatlantic cables. And people know exactly when those broke. So they know how fast these sediment flows were moving, and they can go and study them on the seafloor as well if they wish. And this is another explanation, I think a better explanation. Giant submarine landslides instead of an ancient ice age. All of those evidences are very weak evidence for past ice age, but they are actually better explained as part of the flood of Noah. But the evidence for the one ice age is very powerful. It's all over the scenery. You can see it in alpine regions, wherever there's lots of ice.
And can we undoubtedly point out the border of the ice on the Earth, from the ice age?
Yeah. You look for diagnostic clues. And so what do you look for? Some of the things I've mentioned, scratch marks, glacial till. Something else I didn't mention is boulder clay. At the edge of ice sheets, you often find that it leaves behind boulder clay. Boulders, but inside clay. And most of London is actually on boulder clay. When people dig down to make the tube system, the underground system, they're digging into boulder clay. When people make big buildings, they have to go very far down because it's on clay. That is something that's really clearly a result of ice on the edge of the ice sheet. So we have scientists have a very good idea of how far the ice moved in England. But the same evidences are found all over the world where there's been glaciation. You can see in North America how far the ice came down. If you find an esker, that ridge, even though it might be hundreds of kilometers from ice today, it's absolutely positive that ice sheets once came down that far. That's the only explanation for making an esker. Yeah. So I'm sure there's some margin of error for where to draw the edge of the ice sheet, but people have a pretty good idea. There's not much controversy about that.
Thank you. We have two more questions. One specific question and a more general question on the link between the biblical timeline and global warming debate. So prepare for that one already. But the more specific question is, the Jacobshaven Glacier moves down in a U-shaped valley. From Sweden to the Netherlands, it is horizontal and flat, a many thousand kilometer wide ice field. A question to you, how did that move? Although you might say the valley is flat, every valley still has an elevation between its source and its terminus. And it doesn't, even if it's quite a flat valley, it's still moving downhill. For a very short distance, ice can move uphill over a ridge if there's enough mass, but actually ice is always moving downwards through gravitational influence. I suppose it's quite possible that if there was a sudden earth movement because of an earthquake, you could have a catastrophic flow of an ice. So there have been, just in history, a few times a glacier has moved quickly and it's resulted in devastation. In fact, there was a book I remember reading quite a long time ago by a secular author called Ken Follett, and that was exactly what he imagined, a sudden movement of ice, and it caused destruction, like a mud flow, but in this case, ice. So yes, even though the valley is very flat, it's still actually able to move. One of the things that causes the movement, the lateral movement, is not even just the gravitational pull downhill, but it's the fact that ice is being held at the top. It can't build up increasingly height forever. As ice lands on the top of an ice sheet, it will spread out, it will move out. As the ice, because the ice is, it's not actually just a physical solid, it actually behaves like a plastic. So as you add lots of weight at the top, it moves down and outwards. And so even if it's a very, very shallow valley, it will still move sideways. Then one additional question in between. On this, the plastic movement of ice, how will the plastic movement of ice have been able to overcome the resistance of being frozen on the ground?
Okay, well, it's a solid, but it behaves more like a liquid. If I say to you, if you imagine a sheet of glass, can glass flow? Did you know glass is not a solid? A sheet of glass is not solid. It's actually a liquid. And if you actually look at a really old pane of glass from the early days of glass making, and you take it out of the window frame and you turn it sideways, you'll see it's thinner at the top than at the bottom. It's fatter at the bottom. Why? Because the glass actually has flowed down the pane. Okay, glass is not a solid. Actually, it's liquid. It looks like a solid. If that's true of glass, it's certainly true of ice. You can freeze it, of course, and it can be cold, but it can still flow. It can still flow, especially under great pressure.
The last question. How does rejecting the biblical timeline affect the current global warming debate? To end with.
That's a topic in itself, okay?
Next time.
What I would say to you is this. Christians who believe in creation will have different opinions about that question. I think it's true to say that if you went back 20 years, Creation Ministries International, people like me would say, we don't really have an opinion. We don't think it's really that relevant. But just about 3 years ago, I and some other leaders in the organization around the world, we thought we need to answer this question because we get so many questions about it. So to give you a very small answer to this, we decided to write a paper, a position paper for CMI. And our paper basically gave all the scientific evidence that is used in this debate. It analyzed it and assessed it very calmly. It's a long article. If you go to creation.com and type in climate change, you will find this article by Dr. Don Batten. I was involved in this article because I'm not an expert, but I've read hundreds and hundreds of articles on the subject. I've read many books. I continue to read. I love the subject. It's interesting. And so we looked at this paper. We gave it to meteorologists, both in my country and in North America. One of my colleagues actually is 38 years working in the meteorological office in the UK called Andrew Sibley, and he checked this article. And so we had experts check it, and then we published it about 1.5 years ago. I expected a lot of controversy, but actually it was very interesting. Good debate. You can find that discussion at the bottom of the article. In a nutshell, I believe the planet has warmed in the last 25 years of the 20th century. If you go from 1980 to the present day, it's warmed by 0.5 to 0.6 degrees Celsius. Real warming. The question, of course, in total, that's significant. The question is, do we cause it as humans by releasing carbon dioxide into the atmosphere? Do cows cause it by belching methane gas into the atmosphere? Should we take action now to save the planet for our children? These are big questions. If we are the cause of most of that warming, perhaps we should. But I do not believe that the evidence is absolutely convincing that we are the main cause for the warming. We had warm periods in the past. In medieval times, you had very warm northern Europe. If you go back to just the 1500s, when Henry VIII was king of the UK, he had nearly 200 vineyards himself, his personal property, growing grapes and making wine. We don't do that today in the UK very much. It's not. There is a little bit of wine growing now, but he was growing grapes in a big way. But then, a few decades later, into the 1600s, and even as late as the middle of the 19th century, there was the Little Ice Age. Some people have heard of it. That gets forgotten in this debate. But in the Little Ice Age, there were frost fairs, sometimes lasting for many weeks on the Thames. The Thames froze, the River Thames through London froze absolutely solid to a depth of 30 centimeters. People were there all day. It lasted for weeks. There were several times when you could look across the coast from the Netherlands, from France, from the UK in England, and you could see for weeks at a time many kilometers of seawater frozen at the coasts. But people have forgotten this. And since that time, so we had the medieval warm period, we had the Little Ice Age, and now we're back to something that's warmer. There's some natural cycles. How much of the warming is caused by us? Find out more, go to the website, read the article, leave your comments, make your contribution. But there we are. I'm not a complete skeptic. I think we should not be alarmists. That's what I would finish on. We should care for the planet if we're Christians. We should be concerned to pass on this planet for our children and grandchildren, if this planet will still be here. But we should not be alarmed in a way that some people are, who almost worship the planet like it's like a green religion. And I'm not being unkind about them, but if they don't worship God, the Bible tells us they will worship something. They worship the creature instead of the creator, it says in Romans chapter 1. And I think it's sad that some people are doing that. So I believe I'm an environmentalist, but I hope I'm a sensible environmentalist, not an alarmist. So that's probably all I will say.
Thank you. Thank you very much, Philip, for your contribution this evening and your willingness to be with us here in the Netherlands.
It's my privilege.
We wish you God's blessing for your trip back and for your work. People from Creation Ministries International. It's creation.com, very worthwhile organization, a lot of information, thousands of articles. Normally at a meeting like this, where you would be sitting in front of me, we would pass down the gathering. Pardon, ik word herinnerd dat ik nu Engels spreek en dat hoeft natuurlijk helemaal niet meer. Ik heb Philip bedankt voor zijn tijd en ik wens hem van harte God zegen. Kijkt u op creation.com, wat u daarboven ziet. Normaal gesproken zouden we met de collectezak rondgaan en zeggen: u kunt deze avond mede mogelijk maken om de gemaakte kosten te dekken. Philip is hierheen gekomen en zijn organisatie, net als bij Logos, we leven van uw steun. U maakt het mogelijk. Maar dat lukt niet zo via een livestream. En daarom wil ik u wijzen op de mogelijkheid om het Logos Instituut financieel te steunen. In de omschrijving op YouTube staan de gegevens. U kunt ook de doneerbutton, de QR-code, kunt u scannen, die nu zichtbaar is. Of logos.nl/doneer. Het is van harte aanbevolen. We doen elke maand deze bijeenkomst. En we zien, nu hebben er enkele tientallen mensen zo gekeken. En je ziet de lezing van vorige week van Nathaniel Jensen. Die is al meer dan 600 keer bekeken. En zo loopt dat op en groeit dat. En u maakt dat mede mogelijk. Hartelijk dank daarvoor alvast. We waarderen het ook als u zich abonneert. Als u op het YouTube-kanaal kijkt, kunt u alvast herinneringen instellen voor de volgende bijeenkomsten. De volgende keer zal 8 juni zijn. En we hopen dan de Canadees-Nederlandse oud-testamenticus Cornelis van Dam in ons midden te hebben. Hij heeft een boek geschreven, een Engels boek, over Genesis. En hij zal spreken over de vraag: hoe kun je de letterlijke lezing van de scheppingsdagen verdedigen? Het boek In the Beginning heeft hij daarover geschreven. En dat boek, de recensie daarvan en een interview is te lezen op logos.nl. Het boek is ook te koop op de webshop van Logos. Houdt u onze agenda in de gaten, niet alleen voor de livestreams, maar ook voor de andere evenementen. Nogmaals hartelijk dank voor uw aanwezigheid, uw betrokkenheid. We waarderen dat zeer. Een goede avond en graag tot ziens via de livestream of op live events. Dank u.